And we are rolling. This is actually, it looks at this particular point that we're getting more and more of the sun visible. Earlier, the visible area of the sun was up here and coming around this way. The contraption that you're looking at is called a sun funnel, and basically it's a funnel that is mounted to the objective lens of a telescope. And yes, you do see the warning label on the scope saying don't look right at the sun, so we're not really doing that here. Rather, we're getting a good view from the funnel, and that way we're able to focus the image of the sun onto a larger area such as the paper here. I also happen to bring with me a quite large lens, and when I did an experiment before leaving the house earlier, I noticed that its focus point was way too small, which meant that it would be concentrating all of that light and all of that image onto a pinpoint area, which would make it practically unviewable. I've been noticing I'm needing to move this as I've been chasing the sun around. Oh, there we go. This isn't the best of conditions, but it's actually pretty good, all things considering. Something that I haywired together at the last second, almost literally. And when I was making this, I also made a little tab at the end of this duct tape here so that I could pull the I can't say the ground glass, so I could pull the parchment paper off and drop a different lens down the funnel. After a lot of this is over, I'll show you how all that was put together, and it was kind of a fun thing to do, really. When I was originally going to do this, I was going to have a 30-year-old camcorder focusing on this. Primarily because I could stop its lens down and get a better exposure. But the way I'm having to chase the sun around with this, I would have to move the telescope, move the camera, move the telescope, move the camera, and it would have wound up being a pretty awful pain in the tuchus to do. Again, chasing the sun around as we're going from one side to the other. It looks like, oh, I should have brought that ruler with me. Looks like we're having a larger area of the sun being more and more visible. And the shaking that you see is caused by the wind. You can see from here we go. Maybe I could get this to zoom in. Okay, focus. Focus. So you can see from the movement in the trees. Now it's going to make a liar out of me. You can see from the movement in the trees, it's a little windy here. It's not too bad. Yeah, now we can really see the texture in the paper. And actually, this will give me a chance to really focus this. This is exactly why, if I'm taking an image of the moon on a using a zoom lens on one of these things, I absolutely, positively insist on using a tripod. Here I'm cutting off the edges of the sun again. And we're going to kind of sit here for a moment as we chase the sun across the paper here. With this amount of magnification, you can actually see the sun moving across the paper. There's the little tear in the corner there that we can use for a reference. It's getting closer. The wind isn't helping us much here. And closer. And we'll go back over to the other side.
I should have brought those Kleenexes with me.
And we can also see the sun moving downward in the image as we're chasing it. As we're chasing it across the sky. It's kind of interesting. Tamitha Skov was talking about having gray line conditions on the radio throughout the eclipse. And so for an experiment, I turned the radio to KFAB in Omaha, which is pretty decent reception from down here in the daytime if you have a good radio and if you're not near where there's a lot of interference. And I found that I was actually able to pick up KFAB with relative ease. And now as I'm sitting here, I'm listening to the car, and I'm no longer hearing KFAB. So I imagine our E layer is moved up to a place where it's no longer reflecting the signal. So far we've been at this part of it for just shy of 9 minutes. And it's kind of tough to see trends, but if you scrub this video back to the beginning of it and then come back to the part where we are now, you'll notice that the area of the sun has been getting larger and larger as we go. In a weird sort of way, and kind of off the beaten subject, but not really, this is how This is how the laser head in your DVD player or Blu-ray player or CD player tracks its way across the disc. In the laser head, there's a lens that moves back and forth, trying to keep the laser beam focused onto the disc surface. And it's not really a matter of keeping the laser beam itself focused, but rather focusing what the laser beam is looking at onto the sensors in the head. And moving the head back and forth as the head is tracking the disc from the inside out is a motor which is attached to a worm gear. And what happens is the electromagnet that moves the lens itself back and forth moves the lens to a certain spot, and when it gets to a spot that it's not really going to be able to hold on to the image anymore, it tells the motor to turn the worm gear just a little tiny bit. And they're playing this crabbing back and forth movement as the player tracks the disc from the inside out. You can actually see this is getting bigger and bigger. Yeah, I know, I probably said that for the umpteenth time now, and you're like, oh, she's saying this thing is getting bigger all the time. Now, there was originally a question which came up a time or two. This is JB Hunt taking off. It's a question which came up a time or two. If the sun and the moon both move from east to west, then why does the eclipse move from west to east? JB Hunt. And the answer is that as they make their pattern, or as they make their trek, their travel from east to west, from our vantage point here on terra firma, they're pretty much in a race with each other. So this is not exact, but it's enough of a mental illustration to give you the point. If the moon is over, say, Indiana, the sun would be over the East Coast, and so therefore it's casting a shadow around Wyoming. Yes, I am making this up as I go along. As they're moving from east to west, they're in a race with each other, you could say, with the sun actually moving faster than the moon. So when they get over, say, Nebraska, the sun has caught up with the moon and is getting ready to pass it up. So that by the time the moon is over Denver, the sun has already made it to Wyoming. And when the moon finally reaches Wyoming, the sun's already off to the east coast. And the sun has already passed the moon up, and therefore the shadow that's left by the moon moves eastward to Missouri, Illinois, Indiana, Ohio, so on and so forth. If you have a flat map of the United States, you can try that for yourself using a flashlight and your fist. And you start with a flashlight playing as the sun and the moon as your fist. And run that kind of trajectory, run that kind of path as you go across the map, and you can see that as you're moving both items, the flashlight and your fist, westward, the shadow created moves eastward. Getting up to the 17-minute point here, we're almost up to the point where the sun is about halfway exposed. You can see, you can almost cut a straight line there and there, and see that the moon is, the edge of the moon there is about to that point. Well, if anything else, one thing I can chop off my bucket list, or check off my bucket list, would be chasing the sun around with a telescope. Coming up to the 20-minute mark before long. All in all, this is a really cool gadget. Might be fun to try and refine it further. And see if perchance I can't catch some of the sunspot activity. Of course, in order to do so, I'm going to have to find a better way to track Old Sol, as it were. Large telescopes use clockwork to do this. Well, anymore it's servo motors, but the idea is pretty much the same. Here I'm doing this manually, grabbing the tub that I'm standing the telescope on and moving it back and forth. Actually, I find that a much more accurate way to move the telescope. If this were on the ground, I would be moving one of the legs in order to do this. I would imagine by now totality has moved off to somewhere between Illinois and Indiana.